Hi, my name is Nathan McCollum with the Department of Emergency Services for Indian River County, and we want to thank you today for joining us for this most important program. Today we're going to be broadcasting for you a tour of the National Hurricane Center. Now that's important because we're in the month of May, and during May we do a lot of hurricane preparedness presentations for our citizens and our businesses here in Indian River County. And one of the best ways to know what's going on with hurricanes and how hurricane forecasting is done is to see the National Hurricane Center. Now we know it's impossible for everyone to go to the Hurricane Center and see the different equipment that's there. So we went down there in cooperation with the school district here in Indian River County, and we produced this video that's about 50 minutes long, and it gives you an in-depth tour of the National Hurricane Center, the people that work there, the responsibilities that they have, and how they actually come up with a forecast for any hurricane that may be threatening the United States. So join us now as we look at this most important program, and once again, thanks for joining us today.
Welcome to Notebook, a public affairs program sponsored by the School Board of Indian River County. Notebook focuses on topics of interest to students and parents. And now, here's the host of Notebook, Janice Karst.
Welcome to this very special segment of Notebook. We're here at the National Hurricane Center in Miami, and Nate McCollum with the Emergency Management Services of Indian River County, with whom most of you, I'm sure, are familiar because of his hurricane updates and tropical storm updates on Channel 13, has been giving us a great tour. And Nathan, tell us a little bit about what we're going to see today, what this program is about, and why we're here.
Well, Janice, we are in for a great treat today as we take a tour of the primary agency responsible for forecasting hurricanes and tropical systems in the Atlantic, the Gulf of Mexico, the Caribbean Sea, and the Eastern Pacific Ocean. And of course, that center is the National Hurricane Center here in Miami. Now, the National Hurricane Center not only does hurricane forecasting, but they take care of pretty much of everything that deals with the Atlantic Ocean, the Gulf of Mexico, and the Caribbean. And we're going to take a tour of this most important facility today and give our viewers at home a chance to see and meet some of the people at the center here. You hear us talk about them quite a bit during June, July, August, the hurricane months, and we want to take this opportunity to come down and let you meet the people and see the center and have a better understanding of just what happens here at the National Hurricane Center. So without further ado, let's go ahead and start our tour. The National Hurricane Center is just one of the many weather service agencies which make up the National Oceanographic and Atmospheric Administration. And this administration is under the guise of the Department of Commerce for the United States. Now here at the Hurricane Center also is the National Weather Service Office for Miami, and together they help forecast all of the systems in South Florida. The National Hurricane Center is part of a larger office now known as the Tropical Prediction Center. Hurricane specialist Max Mayfield has generously offered to give us a video tour of this most important facility. We're here at the National Hurricane Center today with Max Mayfield, who's one of the hurricane specialists with the National Hurricane Center. And Max, we're enjoying a great tour of the Hurricane Center. Tell us exactly what is the Hurricane Center's responsibilities as far as the Atlantic and the Pacific Ocean?
Okay, the names have actually changed a little bit here a couple of years ago. We still have the National Hurricane Center, and that really consists of 6 hurricane forecasters. And obviously our primary mission is to issue advisories on tropical depressions, tropical storms, and hurricanes in the Atlantic, Caribbean, Gulf of Mexico, and the Eastern Pacific. In the Atlantic, we average between 9 and 10 storms every year, 6 of which become hurricanes. In the Eastern Pacific, we actually average 16 storms, 9 of which become hurricanes. This year was very, very busy in the Eastern Pacific. We don't hear too much about those, but we actually did have a very significant loss of life in Mexico from one of those hurricanes. Hurricanes may be the primary mission, but we do other things as well. The big umbrella here is now called the Tropical Prediction Center, and they changed the name really to better emphasize the other things we do. We do a lot of aviation forecasting, marine forecasting. They do a high seas forecast, for example, that goes from Africa almost all the way to Hawaii. The same thing for aviation products, both the Atlantic and the Eastern Pacific. We do several different analyses, surface and up-air analyses, and satellite interpretation messages that get transmitted to a variety of users. In particular, all the countries down the Caribbean use these products. They have some excellent meteorologists in these countries, but they don't have the money to put into computers or into reconnaissance aircraft or satellites or radars, and so we feel like we help these countries out quite a bit.
I know in the Atlantic region we all count tremendously on the forecast from your office here, and specifically in Indian River County, all of our forecasting is done from the information from your office. I know that there's been a lot of changes as far as technology goes to actually assist with your forecasting capabilities, such as improved computers, satellites. But again, you have a new jet airplane out there now that's obtaining some of that information. Can you elaborate on that a little bit?
Technology really has improved, and we'd like to think we could get the job done with fewer people because of technology. The truth is there's so much more data to look at now, and it's still a human that has to make that subjective call on the forecast, and especially the watches and warnings. So we are very excited about the technology, and the bottom line, as far as I'm concerned, is it really doesn't matter if we have the best aircraft on the planet, the best satellites, the best radars, the best computers, even if we have the best computer models, and even if we made a perfect forecast, if we really don't communicate that effectively to folks in emergency management and the public, we really haven't done our job. It really doesn't do any good to even make a perfect forecast if you don't get the word out. So that's why we really rely on you all and the media to help us with that. You talked about the jet. The truth is that almost all the operational reconnaissance is done by the United States Air Force Reserves. They fly C-130 aircraft at Keystone Air Force Base in Biloxi, Mississippi. They've done just an outstanding job for us for decades now. NOAA has 2 P-3 aircraft that they fly occasionally in hurricanes, primarily for research missions. But while they're in there, they obviously share the data with us in real time as well. And then we've been very fortunate to purchase a jet aircraft here, which was flown last year for the first time. Some really good things came out of that. Even though it was not a very active season, we put in 2 systems in the Atlantic and 1 in the Pacific. And as the jet came on board, they had to redesign the drop-in zones, these little instruments that are released from the aircraft, and they'll go from flat level all the way down to the surface. The old drop-in zones that we had did not work in the eye wall. The new ones, they're GPS, global positioning system drop-in zones. They experimented in Hurricane Guillermo in the Pacific this year, and it was sort of just a fluke. They said, well, let's go ahead and try to drop some of these in Iowa and see what happens, and they did. And not only did they get some good data, they got data all the way down to the surface. So for the first time, we were able to really look at some really good wind information in the eye wall itself. We've always had some uncertainty in estimating the surface wind speeds. Even though we have aircraft at flight level, that's usually about 10,000 feet in a major hurricane, and now we actually are getting to see what's really going on down the surface, and that's exciting.
And we hope in the future that that's going to provide us even more information as we monitor those storms coming across.
Now the jet is really intended for surveillance. We differentiate between reconnaissance and surveillance. The reconnaissance, they fly through the eye of the hurricane, give us that detailed information in the eye and in the eye wall itself. The jet is flying in the environment around the hurricane. The idea there is for it to provide information on the steering flow that will, eventually steer the hurricane. It will also give us, since the jet flies about 45,000 feet, give us some good upper level wind data as well. We hope it will improve both the track and intensity forecast, but we still can't expect miracles on this. It's not a trivial job to even design the flight plan to get a payoff 2 or 3 days downstream there. You really have to fly in the environment all the way around the hurricane. I think that's one thing we learned this year. It's going to take some time to get a large enough sample to really demonstrate that we've improved the forecast.
And I can't emphasize enough the statement you made earlier that it's the people that are making these forecasts, the people that are analyzing this information, and your personnel, everyone here at the center is so important. as far as analyzing that information, because when those watches or warnings are issued, that's when people, it's time for them to act, and it's important that that information be accurate.
Well, we have a real dilemma here. We have, the forecast errors have really improved. There's no doubt. For example, the 3-day forecast, the average forecast every 3 days used to be about 400 miles. Now that's come down to less than 300 miles. We're really happy that we've seen the average forecast errors come down, but it's not the average hurricane that usually is going to kill people. It's the one that's not well behaved, that does something unexpected, and we know we still have a long ways to go. The computer models have gotten the forecast errors down, but we still look at several different computer models that are never in agreement, and we learned not to bet the farm on one particular model. We don't want to do this windshield wiper effect, where we may forecast it to North Florida one time and South Florida the next. That's not a nice thing to do to emergency management or to the marine interest out there. So we learned to make gradual changes, and as a result of that, our forecast errors have come down. We still can't expect miracles out of these computer models. You have to have good data to go into the models, and that's why the theory of flying the jet in the environment and getting wind information throughout a large depth of the atmosphere, that is very, very important. And the theory is very sound, and I think we will see a payoff, but it may take a few years.
One final question. All of our viewers know that it's very busy here from June till November with hurricane season, but the Hurricane Center actually does forecasts for many other things in the marine industry, correct?
That's right, and we'll take a look at some of the products that are going out right now. They do the marine forecast for the Atlantic, Caribbean, Gulf, the Eastern Pacific. They do some detailed forecasts within that larger area. They also do aviation forecasting, the SIGMETs, the warnings for aviation, heavy thunderstorms, turbulence, icing, things like that. They're doing this over the Atlantic, Caribbean, Gulf, and the Eastern North Pacific. So there's these guys really they're working 24 hours a day, every day of the year, putting out these routine products that are important to a lot of people that we don't really think about. And then they also support the Hurricane Center by giving us, during the season, the classifications of the hurricanes, the location, and the intensity estimates from satellite. Now, the satellite does a really good job considering it's 22,000 miles up in space, but it doesn't give us that detailed information that we need from the aircraft, and we really we can't afford to keep a plane out there 24 hours a day as much as we'd like to. We're the only country on Earth that can really afford routine aircraft reconnaissance in hurricanes, and we should be very thankful for what these guys do for us.
Max, thanks very much for taking the time to talk to us today, and we're going to go ahead and continue our tour now of the center and the different things that you all do to give an accurate forecast not only for hurricanes, but everything that goes on really in the Western Hemisphere. We asked Max to give us a tour of the actual structure because this is where the specialists will have to stay during a hurricane.
Even the inner walls are poured concrete. They're 10 inches thick. They've got 2 rows of rebar, so the building is going to be here. We can still lose communications, and we're always worried about that. We have a backup plan. The product's going to be put out from Washington if we did get knocked out. And Andrew, our antennas were shredded. The radar went, blew off the building.
Absolutely.
But we stayed up. The backup generators worked, and we kept, we had to get Andrew into Louisiana, so we kept working and did okay. It wasn't exactly a picnic. The air conditioners didn't work, but we kept the products going out.
The Hurricane Center also keeps many records in a library that's been established at the center, along with television cameras for hourly updates during threatening hurricanes.
This is the Data Mobile Home Park after Andrew. That just I had friends that lived out there. This is not too far from my house, actually. Anyway, the bottom line, a mobile home is not the place to be in any kind of a hurricane, even a Category 1. And now the mainly forecast office here, there are several different forecast offices in the state. The MIC here is Paul Hebert, and his group has much of this side of the building. They do the zone forecast, the terminal forecast for aviation, the coastal waters forecast. And the idea under the modernized weather service is as a hurricane gets near land, people need to go to their local NEXRAD weather service office for that detailed information. I could probably name all the 67 counties in Florida, but I don't know all 250 counties in Texas or 180, whatever it is in Georgia. These people, it's their home, their area. They know the detail of these areas that we don't. We walked through the media room a while ago. This is where we have the workshops. We can really display anything on any of the monitors on that big screen in there. It's really a nice area for training. And then we open up those doors like we did for you when the media comes in during a landfall threat.
Just as important as what is inside the building, the vast array of satellite dishes outside the building collect the data necessary for hurricane forecasting.
Okay, the primary observing system for the Hurricane Center is the geostationary satellite. We have two of the big antennas here, one for goes east, one for goes west. We're receiving the satellite imagery 24 hours a day from these satellites that are 22,000 miles up in space. We also have an antenna for the polar orbiting satellites. We have antennas for the aircraft data. When the aircraft is flying in the hurricane, they can send this. They actually bounce it off the geostationary satellite and then back down to the Hurricane Center. We have radios for the, antennas for the ham radio people. They really do us a lot of good, especially in the Caribbean. If there's a landfall and the first thing that goes out is the power in some of these countries. So the only information we get often is from the ham radio volunteers that we have. We're always concerned, if we were to get hit again from a major hurricane, the building is going to be here, we'll still be operating, but we could lose communications. If we did lose some of these satellites like we did in Andrew, we still have backup to some of these systems by landline, some of it by the internet now. We still think we could do the job from here, but there is a backup plan. If we lost all capability, we'd transfer responsibility to Washington, the Hydrometeorological Prediction Center up in Washington.
Once the satellite information is gathered using the equipment outside the building, the forecasting of the hurricane begins by analysis by hurricane specialists.
We can look at the visible imagery. We can also look at the infrared. The infrared sensor is, measuring the long wave radiation and able to land and see it in the clouds. And the higher up you go in the atmosphere, the colder it gets. So we've got the white areas representing the cold temperatures, and the dark areas representing the warm temperatures. So we can play games with that and make the temperatures appear whatever color we like. This is one where the blue is minus 50 degrees. Green minus 60 and red minus 70 degrees centigrade. So I can just look at this and I can see where the really cold temperature tops are, and then we can enhance this to our heart's content. We have different enhancements for different things, some for hurricanes, some for thunderstorms, some for the Gulf Stream. In fact, you can see the Gulf Stream, the warm temperature right up in there. Probably shows that better right there. And then as we get a storm, we can zoom in a little bit closer if we like. Here's the Gale Center over the North Atlantic. Again, the visible and the infrared. And let's see if we have anything. We can zoom in as much as we like. We've got a real good close-up of Florida. In fact, it's so clear. When you have strong winds, if this is cold air moving on the warm water, and you get these low clouds like this develop. They're also kind of lined up in lines pretty much parallel to the low-level flow. We can kind of zoom in here, in fact, and see the Bahamas, the Bahama Banks, this milky-looking area right here. Here's Lake Okeechobee, Tampa Bay, Charlotte Harbor, and all these little lakes really stand out. Here's the Cape, and the resolution is really
You're not watching what's
really
going
good.
on in my backyard or anything, are you?
I can't quite do that yet, but that we're getting there. So if we do have a disturbance, obviously we can zoom in. We're actually looking at this area in the Pacific right now. You never know in an El Nino year if you'll have something out of the season. In fact, we had one that was almost a depression here early December in the Pacific. Luckily, it didn't ever amount to anything. But
Are you forecasting the Pacific up to longitude 140? Is that it?
Right. So that goes almost to Hawaii. We also have this, the water vapor imagery. You see this occasionally on TV now. We're used to looking at the visible and infrared. This wavelength, the satellite is sensing radiation at different wavelengths. So this wavelength, we're actually looking at the moisture in the atmosphere primarily at mid to high levels. And we're seeing flow in here that you can't see sometimes on the normal visible and infrared. The red areas represent dry areas, the white a lot of moisture. So you can see how the winds, especially in the upper levels of the atmosphere, are moving on that loop. So the satellite coverage is very good. We have the European satellite. Looks like they're having trouble with it now, but we can see this is Africa. We can see over to the Caribbean off the European satellite. And then as it gets closer to our area, we'll switch over and look at the GOES satellite. There are two, the United States has two, one for the Atlantic, another one for the Pacific. We'll look at over here on another workstation in a minute. But if we had a storm, this is not a tropical system, obviously. This is a non-tropical low out here off the East Coast. The first step in the advisory process is the fixed data. And we have a satellite unit over here that provides us with a location and intensity estimate. We'll come over here, type that into the computer. If it's near land, we'll have reconnaissance aircraft. We'll look at where that data comes in. We'll enter that data. If it's close enough to the coastline, it'll be picked up by radar. We'll enter those pixels in. So one thing, unfortunately, is those center fixes are not always in agreement. You have two satellite analysts that estimate the location and intensity, and they're not the same. If there's a well-defined eye, well, our kids can find that. But if it's not well-defined, there's some scatter there, and we have to smooth that out. And it really makes a difference on where the initial location is, on where the forecast model is going to take it. So after we really concentrate on the current position and the past 24 hours. Some of the computer models need the past 24 hours worth of data. And we'll submit that input data up to Washington and wait a few minutes to get that input back, the output back rather. And then we'll come over here and we have different computer models. This is, you may have a little strobe effect here, I don't know, but this is the global model from the National Weather Service. You can see this is actually a 10-day forecast. It looks real pretty. Unfortunately, out of the tropical areas where you don't have much data, it still is having a hard time. In fact, I think I'll let me go ahead and step through this, and we'll. So this is where we start. This is the low we have off the East Coast. This is another trough over the central U.S. And then here there's a big low pressure system over the Gulf of Alaska. As time goes on here, you can see this system moves off very quickly. This trough off the Pacific coast really amplifies and cuts off a low over the southwestern United States. So in a few days here, we're really going to hear, I'm sure, about a snowstorm out there. And then this system comes across the country. It stays well up north. The flow down here over Florida is pretty zonal, so we're really not pushing a lot of cold air all the way down here. And yet another system drops into the southwest, so things are really going to be active over the western U.S. here over the next several days. So we have several different computer models. Let me look at one, for example. This is from this morning, and let's just look at surface data, and these are actually the boundary layer winds. These are the isobars here, these yellow lines. Here's our low off the East Coast. Here's the high over the western Gulf of Mexico. The winds here you can see are coming from the northwest over the state. That was from this morning. Here we are tonight. Tomorrow morning, they're still coming right down the peninsula. This particular model goes out 48 hours. The high moves over here to South Carolina in a couple of days' time, and the winds go clockwise around the high, so the winds are eventually going to come out of the northeast here within a couple of days' time. This is just the surface data. We can look at several different levels in the atmosphere from several different models. And in fact, if we, let's look at this will be the aviation model, and let's just look at the Atlantic. This is from last night. It's not in yet from this morning. And let's go up to about 5,000 feet in the atmosphere. And we can see all the way from basically from Africa. Here's Africa here over to the United States. Here's our low pressure system off the Atlantic. We can see what this particular computer model does for this system out for 3 days' time. And I know I said this earlier, but the computer models really have improved. The problem is, out over the ocean areas where the hurricanes are, we don't have a lot of data that goes into these computer models, so you just can't expect miracles. And that's why the idea of having this jet aircraft fly in the environment around the hurricane to give us wind information throughout a large depth of the atmosphere is so important. This is, we were just looking at the Joint Typhoon Warning Center. This typhoon Paka really went over Guam right here. This is the forecast. They had a real good forecast on this. In fact, let's look at a satellite imagery now and see if they're still transmitting. This is when it hit. It actually went over the Mariana Islands here. Guam is right here. They actually had a wind report of a gust to 205 knots, so that's about 235 miles per hour. They're a little elevated there, but there are people living where that elevation is, so they really got clobbered. And Guam was actually on the weak side. They were on the west side of the eye. But that was a real thing there. So anyway, that's an idea. We'll look at the computer models, and then we'll actually make the forecast. The track forecast goes out to 3 days, along with the intensity forecast. We have several different of the computer models to make the track forecast. We're really limited on the intensity models that we have, and there's a lot of work that needs to be done with intensity forecasting. We do a pretty good job in general. The averages are very good, but we still hardly ever catch those rapidly developing hurricanes.
Right.
The Andrews, the Gilberts, the Hugos, we really have difficulty catching those, and we need to do better at that. We have radar imagery. This is, the weather is so beautiful everywhere over the southeast that there's not much on here, but we have composite data that we can look at. We also have the Doppler pup. We can actually dial into any station here. I don't think we're going to have anything. It's been too clear here for too long. Let me see if we have a loop still on here. If we have Danny. Okay, that's the base velocity. Let's see what we have over here. Nope, we don't have it on here. We must have just taken that off. The Doppler radar is really good because in addition to the reflectivity data that we've had for years, the precipitation patterns, we're also getting velocity data. And what that means is we're getting some wind information, how strong the winds are at certain levels of the atmosphere, information that we've never ever had before. But you can't wait for the hurricane to get within radar range to put up watches warnings. The Earth's surface is curved, the radar beam is straight, so by the time you get out a couple hundred miles, that radar beam is way up in the atmosphere and is often overlooking the top of the hurricane. So you can't afford to wait for the hurricane to get within radar range to rely on that. But this is where they make the marine forecast and the aviation forecast, and there are a variety of products that they're putting out every day. They do one specialized product for the Gulf of Mexico. It's kind of a combined marine aviation product that combines ceilings, visibilities, wave heights, primarily for the helicopter support of the drilling platforms in the Gulf of Mexico.
Max, let me ask you a question. The training that your forecasters have and the training that everybody here at the center has, we know there's a lot of students involved in our school system that may be interested in meteorology as a career. What are they looking at as far as their educational backgrounds?
Well, we're all meteorologists here. Several people have degrees in meteorology and computer science. Chris Bowie here at the Marine Forecast today has a degree in meteorology and a master's in computer science. You can't have too much computer science these days. As you can see around here, we have more computers than people. So, you know, if you're good at the sciences, especially math and physics, you know, it's a really exciting field to get into, and it's the only field that I know of where you can, everybody has their own lab. I mean, you go outside, you look at the sky, you look at how the winds are blowing, how the clouds are moving. It's just like walking into your laboratory every day.
Very true.
Let me, Chris, can I bring him in for just a couple of minutes here? Do you want to show him, or do you want me to do it? I'm wired. Let me just get him in and out. He's got a product here. Not too many years ago, we had humans that actually plotted the ship reports. We get several thousand ship reports every day from around the globe. They'd plot that by hand, then we'd analyze it by hand, and we'd transmit that out to several different places, especially in the Caribbean. Nowadays, the data is plotted on the computer. You analyze it on the computer, and then it makes it very easy to transmit that to a variety of places. They do an analysis here from Africa over to the Hawaiian Islands. That's one thing that's very important in the tropics. The computer models do a good job. You know, they're much improved, but they do a better job when there's a big temperature contrast. If it's cold up north and warm down south, in the mid-latitudes, these computer models are really improved. In the tropical areas, I mean, it's a homogeneous atmosphere. The temperature is the same here as it is in Africa, and it just doesn't vary that much. So the computers still have a long ways to go, the models do, before they can really solve everything for us. This is an example of the final product here. This is from this morning, and here's this complex low-pressure system that we were talking about. You can see all these ship reports, and there are actually a lot of ship reports on the North Atlantic, but look at the tropics where the hurricanes form. We don't have hardly any data. We got a handful of ship reports of the whole tropical area. And we basically go all the way out here past the Hawaiian Islands. We have upper air analyses as well. The gentleman over here is at the aviation desk. They do several different products. Again, I think we mentioned this before. They do these, they're called SIGMETs. They're warnings for aviation, for thunderstorms, for turbulence, for icing. When you're flying in a plane, the pilots are aware of where the significant weather areas are, and we do the area for the Atlantic, Gulf, Caribbean, and the Eastern Pacific south of about 32 degrees north latitude. These segments they put out, they also cover volcanoes, and the one down in the Caribbean, Montserrat, that keeps erupting. Every time it erupts, they can see this on satellite, and they'll put out a segment for that type of disturbance as well. Chris Burr is the marine forecaster, and he puts out a high seas forecast that goes from actually about 35 west. Yeah, that area there covers most of the Atlantic and the Caribbean and the Gulf of Mexico, and then he'll turn around to the same thing for the East and North Pacific. And actually the South Pacific, there's one small area there in the South Pacific that they do the high seas forecasting for as well. They provide the support for the Hurricane Center as well in the Dvorak technique, where they estimate the location and intensity of the tropical cyclones. They do a rainfall program that is very useful to the people in the Caribbean, not just for hurricanes, but for African waves or any type of disturbance that's propagating through there that will cause some major rainfall. One of the biggest problems they have in the Caribbean is the rainfall. They usually have more loss of life from the rain than they do from anything else.
Along with satellite information, Air Force reconnaissance is very important in gathering the most current information on the conditions as a hurricane continues to strengthen.
Okay, besides coordinating the missions and making sure that they come off as scheduled to satisfy the requirements from the Hurricane Center here, we also handle the data when it comes in from the aircraft. What we have here is this system here and also on the tube there. It's a satellite link with the antenna on the roof here that talks directly to the aircraft. We can send messages back and forth real time. Their observations come in real time. We have observations as often as a packet will come in with observations every 30 seconds. And so we get this data, comes into the Hurricane Center here, we process it and get it to the forecaster almost immediately. And with that, the forecaster can have the information that's necessary to put out the warnings and watches that they're required to do to protect the country. And then once we get that data and we get it to the forecaster, we also send it out across the world weather net throughout the world, so other forecasters can have the benefit of that data also. We also work some with the NOAA research planes when they're out flying. Sometimes they'll actually do some operational missions for the Hurricane Center too, and any data that they get, we also pass that directly to the forecasters.
This is what it looks like. The people often ask how the plane flies through, and in this case, actually they started up here, it looks like, and from the northwest. This was Hurricane Erica from last year. They flew through the eye right in here, out here about 100 miles, and then up to the north, and then went back through the eye again, which had moved from here up to here in this couple-hour time frame. So this is really good detailed information. We get the wind information every 30 seconds now. It really very well defines where the maximum winds are, which is very useful to us. And also they'll release one of these little droplets on we talked about in the eye itself, and it'll drop down to the surface and give us that minimum central pressure in the eye of the hurricane.
This data, as I said, comes to us from the satellite, and we'll get these bulletins every 10 or 20 minutes, and it's a matter of 2 or 3 minutes before we have that final copy there for the forecaster to look at and analyze. So it's in the current days of computers and satellite communication, things are much quicker and much more effective than they used to be in the older days of HF radio and without satellites and the ability to transfer and transmit this data like we have now.
This shows some of the different computer models. You know, we talked about the different models that we have to look at. When Erica was located out here east of the Caribbean, and here are the Lesser Antilles, here's Puerto Rico. When Erica was centered right here, some of the computer models took it in almost into the Caribbean, some turned it up more towards the north. You can see how much scatter we have. These are 3-day forecasts. Here's one that actually takes it over the Virgin Islands and towards Puerto Rico. Here's another one that turns it to the west. Most of the others are in pretty fair agreement along this line here, and that's what we actually did for our official forecast. But there's always some scatter in the different computer models. Here's another example. This is it's getting closer. It's about 400 or 500 miles east of the Caribbean at this time, and the computer models are basically saying in 3 days' time it could be anywhere from the eastern portion of Puerto Rico to maybe 400 or 500 miles northeast of Puerto Rico. And that's the uncertainty that we have to deal with every time we make a forecast. So when people ask us, you know, exactly where is that landfall going to be and exactly what time, we know what the limitations are. The average forecast there in 24 hours is about 100 miles. In 2 days' time, it's about 200 miles. And in 3 days' time, it's a little bit less than 300 miles now. And those numbers actually have been coming down, but we need to come down a lot farther.
As our tour ends, we did want to show you the picture that you're probably most familiar with during television coverage, and that's the hurricane tracking map here at the center. The hurricane tracking map is a quick visual aid for people to look at to see just what the track is of a hurricane that may be approaching the United States. Historical data is kept on computers, but this provides a quick reference for the path and direction of any hurricane. Well, it's been quite a tour here at the National Hurricane Center, and we want to thank Max Mayfield and all the staff here at the Hurricane Center who generously gave of their time so that we could take this video tour and present it to you on our cable channel. And we also want to thank the staff of the Notebooks with Vero Beach High School who produces the Notebook, because without their assistance today we wouldn't have been able to provide you this video tour. We're all well familiar with the hurricane map that we see here on television during hurricane season, and we hope this map is not filled with too many storms for 1998. But if we do have a lot of storms, or even if we just have one storm, we can all be thankful in the knowledge of knowing that the people here at the Hurricane Center are monitoring those storms, and they'll let us know through watches and warnings if we need to take any protective actions. Janice, I want to thank you all once again for allowing us to come down and do this video tour for our citizens in Indian River County. And I hope that we provided a lot of good information and give everybody a good idea of just what happens here at the Hurricane Center.
Nathan, this is a perfect example of collaboration between the county government, your department, and the school district, because not only has this been educational for us while we've been here, but to be able to provide to our residents of our county the information that is so critical to us during not only storm season, but all throughout the year. We really appreciate everything that you do for us and for everyone in Indian River County, and it's been a real pleasure to be here at the Hurricane Center. I've been so impressed with the staff and the equipment, and it really makes it so interesting. This is like a science class field trip that we can be able to use for our students and for our residents alike. So again, thank you, and thank you for joining us, and we hope to see you next time on Notebook.